see if you could do number 1, 2, and 3 for me. That's real plenty. And I'm gonna let Shazay do the rest, right? But you know, it's real quick, real easy stuff. So let me see how well you're doing at it. So number 1A, you're doing number 1, polar number 1, polar number 2, polar number 3, right, Caitlin? I'm punishing you because you're quiet, right? So let me hear it.
8 brackets 4.
3 brackets 4. So all she did was she take this A is equal to 4 and she put it where A is. So now you have 3 times 4, which is what?
12.
12. Very good. This one?
4 brackets, another 4 plus 2.
Which is 16 plus 2, which is?
18.
Come again.
5 plus 2 in brackets 4.
Which is 5 plus 4 2s are 8, which is?
13. 14 minus 3 brackets 4.
Which is 14 minus 4 3s are 12, which is?
2.
2. So number 2 and number 3, let's go. If T has a value of 3, then what will happen?
4 in brackets 3.
Which is?
12. 5 in brackets 3 plus 4.
5 3s are 15 plus 4 is 19.
Yeah.
Alright, come again.
6 in brackets 3 plus 9.
6 3s are 18 plus 9 is 27.
Yeah.
Come again.
16 minus 5 in brackets 3.
So that's 16 minus 15, which is?
1.
Alright, number 3.
6 minus 5 in brackets
Which is?
1.
17
minus 3 in brackets 5.
3 and in brackets 5, which is 17 minus 15, which is 2.
Yeah. 3 in brackets 5 minus 4.
15 minus 4, which is 11.
6 in brackets 5 minus 14.
6 5s are 30, minus 14 is 16. Alright. So Shazay and Scotia, are you okay with all of these guys here?
Yes.
Alright, Scotia, you alright? Alright, nice. So we could see a lot of them are pretty easy. Shazay, see if you could give me number 4 and number 5.
Okay. So 8 in brackets 9.
16 minus 9 is?
7.
Alright.
6. 8 in brackets minus 45.
6 8s are 48.
Yeah.
Minus 45 is 3.
8 squared minus 8 squared is 6.
8 squared, yes. G is 8, so 8 squared is 64. And then this one is what?
4 brackets 8 squared is equal to 256.
Yeah, well, what did you do? Did you square the 8 first? Did you multiply 4 by 8 first?
I think I squared 8 first and then multiply.
Alright, you cannot multiply, and this is a thing that my form 3s were doing, but you cannot multiply the 4 by the 8. Yeah, because the 8 is being squared. The 8 is in brackets, so you had to do the brackets first. So the 8 is being squared, so you have to say 4 times 8 8s are 64. So it's 4 times 256.
Yeah.
Alright, good job.
Actually, did that this time. I just multiplied 4 by 8 and squared it, and I get 1024, and I was like, okay, I'm probably not correct. So that's
Yeah. So the reason why you can't do that is because 8 squared is really 4 times 8 times 8, and
yeah.
so if you multiply the 4 by the 8 first, whatever is the answer for that, you would have to multiply that by 8 again. You understand? Right. So the easiest thing to do is to just square the 8 first. And Caitlin, you okay with this? Squisha, you okay with this?
Yeah.
Alright, number 5, real quick. Let me see.
4 bracket 6 minus 7 is
This one. 4 in brackets 6 minus 7 into what? So it's just 7. How that B was so close there, you know? It's badly written. Just now I lost my thing here. Right, yeah. So we'll get rid of that B. So 6 4s are 24.
Yeah.
Minus 7, which is
17. Second one is 45 minus 5 open bracket 6 close brackets is equal to
6 5s are 30.
Yeah.
Which is 15, right?
The
56.
one is 56 plus 6 is equal to 62.
Next one is 40
minus
minus
6 open bracket 6 close brackets is equal to
4. Alright, good job. I think this stuff is pretty easy for you guys. There are a couple of them though. So does anybody actually need to do out the rest of these, or are you all okay? Is there any one that you would need to do? There are a couple that I would like you to do. So let's see. How about let's do this one? This one here is who's gonna do this one? Caitlin. And if you do it right there on the page, you don't have to look for it in your book. M is 4, N is negative 2.
3 brackets 4 minus
3 brackets 4 minus
5 brackets negative plus 4.
5 brackets negative 2, right?
Yeah.
Because N is equal to negative 2, right? Alright, plus 4, yes. I didn't see the plus 4 on that side. So what now?
Plus 9 brackets. 4 3 is 12. Positive 10.
Yes, negative 5 times negative 2 is positive 10. Plus 4, which is 26. 12 plus 10 is 22. 22 plus 4 is 26. Shazay, let me get this one.
Two open brackets 4 close brackets minus 2 and negative 2 and 9 brackets plus 3 negative 2 and brackets again.
So 2 times 2 is 4. 4s are 16. So this is negative 16. And then this is 3 2s are 6. But this negative 2 there. So that's negative 6. So negative 16 minus 6 is what?
Negative 22.
Very good. Yeah. When the signs are the same, you add them and you keep the sign. Right? I think all of these are okay. Alright, let's just get these two. So, Caitlin and Shazzy. Let me hear Caitlin first.
5 in brackets, -2, then another set of brackets, -3, cube divided by 10. Multiply the two brackets with, cube the two brackets with.
Cube the two brackets. So these two brackets getting cubed?
Yeah.
No, it's only the -3 is getting cubed. It's only the v squared. It's only the v is being cubed. If the u and the v were being cubed, they would be in brackets like this, right? With the cube on the outside. But in this case, it is only this -3 that is being cubed. You understand?
Yeah.
So I could go 5 times -2, and then let me cube. So where's -3 cubed?
-27.
Very good. So -3 cubed is -3 times -3 times -3. So 3 3's are, this is +9 times -3, which is -27. Right? So this is -27 all divided by 10. Now we can just multiply the 5 times the 2, which is -10 times -27. And this is going to be divided by 10. Right? And we could even put it like this, divided by 10. Right? This 10 will cancel with this 10 to give me -1 multiplied by -27, which is just +27. You okay with this, Caitlin?
Yeah.
Did you get this answer for this one? Did you do this one?
I did it, but I didn't get answer.
Alright, what did you do wrong?
I cubed the 2 and the 3.
Right, I guess, yes. But it's not the u and the v that's cubed, it's just the v alone, right? If it is that the u and the v were cubed, they would have it in brackets like this. You understand that, Caitlin?
Yeah.
Alright, so it's good that we wish to do these things. I'll do some more of these square examples as well. Like, look in this case here, you have not just the a, not just the b, but also the 2. All of them are being squared. So that is how they'll put brackets there. You understand?
Yeah.
Alright, but if it have no brackets like this case, you just have the v cube alone. Shazay, let me hear this one.
Open brackets. Open brackets. -2. I bet it's only. Oh, it's starting that.
So what? U is -2, right?
Yeah.
V is -3, right?
Yeah.
U is being multiplied to V right now, eh?
Yeah.
So I have -2 times -3. But then all of that is being squared, eh?
Yeah.
Right. Now minus
-2 brackets. 5 -2 squared.
So in this case, the -3, sorry, I put Q. The -3 alone is being squared, right? So you see another example of it here, Caitlin. Hello, Caitlin.
Yeah.
Right, so you've seen the other example here where they're squaring the 2 of them, so they put the 2 of them in brackets, right? So that'll be 2 3's, well, the negatives canceling off here, so 2 3's are 6 squared, right? And minus -2 times -3 squared. So 6 squared minus, you have the -2 times 3 3's are 9, that's +9. So +9 times -2 is 9 twos are negative 18, and that's being minused here. And 6 sixes are 36 minus 18, which is 36 plus 18, which is 36. Where's 36 plus 18? 54. Right. So Scotia, you doing okay with the stuff so far? I made some errors, but I understand. Okay, right. Well, I was thinking that you guys would have gotten all of this correct, but I see that you all made some errors. So let me see. Let's do some more of the square ones then. So Caitlin, you do the first one, you do this one, and Shazay, you do this one. Alright? So Caitlin, let me see. X is 4, Y is negative 7.
5 in brackets 4 plus 2 in brackets negative 7. 20 plus negative 15.
6?
Yeah.
Alright. Shazay?
No.
A is 2, B is negative 5.
2, open brackets, 2, close brackets, open brackets, negative 5, close brackets.
And?
Yeah.
So that is 2 twos are 4. 4 times 5. 5 fours are what? 20?
Yeah.
So I'll have negative 20 being squared here. So negative 20 squared is positive 400.
Yeah.
Alright. Okay.
So can you hear me now?
Hey, what's up?
Hi, I had to switch devices.
Oh, okay. Well, you went back on your computer?
I went to my tablet.
Sorry?
I went to my tablet.
All right. Okay. Well, that is good. We're glad to have you here, right? So, are there any of these that you want to go through, or are you okay with all of these guys? Scotia specifically.
I think I'm okay. It had one mistake I kept making when the numbers in brackets and it was squared.
What was the
I
mistake?
used to multiply the numbers first and not square it first.
Yeah. I had my form trees doing that. Yeah. So you see that is an issue, right? So for example, right? See if you could do this one here. G is negative 4, H is negative 5.
So negative 4 in brackets squared by negative 5 in brackets. So square the 4 and get positive 16. And then you multiply that by minus 5. And you get negative 80.
Alright, negative 80. Negative 8. 0 is the answer there. Good job. So just look out for that. That's an easy little mistake to make. And try this one. And let's see. G is negative 2. H is negative 3.
Two in brackets, negative 2 squared. Minus 4. And in brackets, minus 3 squared. So it'll be 2 by positive 4.
So it'll be, sorry, just now.
Okay.
Stop. Alright. So it'll be 2 times, well, this square here, 2 twos are 4, so that's positive 4, right? And then minus you have this 3 squared is 9. Yeah?
Yeah.
So that's 4 times 9. So 4 2s are 8. Right? And then 9 4s are 36.
Yeah.
So 8 minus 36 is what?
Minus 28.
Yes, very good. Okay. So I'm gonna trust that everybody is okay with these guys. Shazay, you okay with all of these guys here, right?
Yes, sir.
Right. Let me just move on to these here now. Now these are pretty easy. Caitlin, Shazay, Scotia. Real quick, let me see it. The first one, Caitlin. We're making y the subject to the formula. So y plus w equals c. What now?
Transpose CW to make it negative. Minus.
So y is equal to c minus w, and that's the answer, right? So Shazay, you okay with that?
Yes, sir.
So now we have the second one, y minus p is equal to m. What to do here, Shazay?
The transpose the P and then become M plus P. Y is equal to M plus P.
M plus p, nice and easy. And Scotia, I have m plus y equals s.
Transpose and it'll be y equals to s minus m.
Minus m, very good. Good job, right? So, Caitlin, Shazay, Scotia. Alright, so Caitlin, we have 3y is equal to c. What to do?
Transpose the 3 so the y equals to c divided by 3.
Very good, Caitlin. Shazay, we have y over c equals w.
You transpose the C and then become Y is equal to W multiplied by C.
W multiplied by c. Very good. And Scotia, y over a equals 2c.
I'm on the a on both sides.
So,
And it cross out to the line.
so transpose the a. If you fling the a across, it's divided by a. So it will become multiplied by a. Alright, and we usually try to write it in alphabetical order. Sometimes 2ac is quite normal as well, right? Nice. Getting a little bit tricky now. Caitlin, Shazay, and Scotia. So Caitlin, the first one, y squared equals s.
Transpose the square so the y equals to the square root of s.
Right. So the square root of s. Does Shazay and Scotia understand how this is possible?
Yes, sir.
Alright, so everybody okay with this, right? So I'm just hoping so. Shazay, you have y cubed is equal to x.
You transpose the cube and then become Y is equal to the cube root of X.
Cube root of x. Same thing like before. Scotia and Caitlin, you okay with this one?
Yes, sir.
Alright,
Yeah.
so you all got all of these correct, right?
Yeah.
So Scotia, you want this one, the square root of y equals g.
Transpose the square root and then take the square.
Y is equal to g squared. Shazay and Caitlin, you okay with that?
Yes.
Alright, very nice. Okay, good. What about this one? Who is going to do this one? T.
I could do it. and it transfers the square and everything, not various way.
So y is equal to
Square root k plus x.
of k. Oh, sorry, x. Well, I could put x plus k. It's the same thing, right? The square root of k plus x and x plus k.
You
Good
can
job.
do s.
S. S?
Yeah.
Oh, that's lovely. This is a nice one. Anybody
Yeah, that
anybody
one
want
some trouble.
anybody want to do S? It's actually really easy. Nobody.
I think something to S, but I don't know if it's correct.
What is that?
I just transpose the R
And it'll become divide by R.
multiply by
You could transpose the R, but it'll be because remember what is this? This is a fraction, so this could also be seen as R multiplied by 1 over Y, and
yeah.
which is equal to W. So if you transpose the R is being multiplied. So 1 over Y is equal to W divided by R. Yeah? So if 1 over Y is equal to W divided by R, well then you could flip the 1 over Y, but then you'll have to flip this one too. So therefore Y over 1 is equal to R over W. Hence Y is equal to R over W. You understand? Alright, there's another way to do it. Alright, there's another easier way to do it. If I want, you could transpose the Y, huh? So I'll be left with R alone is equal to W multiplied by Y, huh? And now that I have this, now I transpose W to get R over W is equal to 1. Scotia, that makes sense to you?
Yeah, it makes sense.
And what about the first way that we did it? Did that make sense to you?
Yeah.
Right, so we have many ways to do these things. Okay. Now this here is a lot of the same stuff. What do you have to make? X the subject to the formula. Caitlin, Shazay, Scotia. Ready? So Caitlin, you have x squared plus a is equal to v. What to do now?
Transpose positive A.
So I'll get x squared is equal to v minus a, and then what?
The transpose the squared, and it'll be x equals to the square root of v minus a.
Very good. Good job there, Caitlin. Alright. Shazay, you have this one. X cubed minus 4 is equal to 5y.
You transpose the minus 4 and it becomes x cubed is equal to 5y plus 4. And then you transpose the cube and it becomes x is equal to the cube of 5y plus 4.
That is very good. Good job, guys. I'm very impressed with you all. Alright. Somebody do this one. Oh wait, no. Scotia, you had to do a is equal to pi times x squared. So what to do?
Well, I wrote it differently. Okay, I just switched it.
Pi x squared is equal to a. That's a good thing to do.
I'll transpose the pi with the a divided by pi.
And then
Transpose the square. So the root of it.
yeah, nice. And what about this one? Anybody want to do this one? Nobody want to do it? Shazay, Caitlin?
I could try. The transpose the cube root, so be w cubed.
X over k is equal to w cubed.
The and transpose the k.
So x is equal to k times w cubed. Then is that okay for you?
Yeah.
All right, nice, lovely, very good. I'm very, very pleased with your guys' performance here. Very.
So you cube everything on that side after.
All right, so at the end of the day, if you look at it here, you'll see that this x and this k, you could put them in brackets because all of it is under the cube root sign, right? So that means you can't do nothing with the x and the k. You had to get rid of this cube root sign first. So when you get rid of the cube root sign, it's just the w is being cubed, right? Now technically everything on this side is going to be cubed, eh? Everything on this side is going to be cubed. But guess what? You only have w on this side. So you'll end up with x over k is equal to w cubed. And then you carry over the k. So x is equal to w cubed multiplied by k, which could also be written as kw cubed. Remember, in a case like this, it is only the w that is being cubed. If the k is being cubed as well, it would be written like this. You understand?
Yes, sir.
Right? So it's only over here you're seeing kw cubed, but don't get mixed up. It's only the w that's being cubed over here. Right?
That's like the ones we did before.
Yes, that's like the ones we did before, yes. Alright, so be careful with that. Look out for your brackets, especially with this one. So who could give me this one? Shazzy, how would you approach this one?
Okay, I have a plus c is equal to the square root of t. And then I have c is equal to the square root of t minus a.
Yes, that is absolutely correct. Yeah, we can't do anything with the a and the c because they're inside our brackets and they're being squared. So we need to get rid of the square first. So this t would be square rooted, and then we could just manage it from there in terms of transposing the a. Right? Scotia, let me get this one. So you flip it around.
Yeah.
Pi c squared 8 is equal to v.
I transpose the pi and the h.
Right, well the pi, very good. So you realize that multiplication is commutative. So 3 times 4 is the same as 4 times 3. So therefore I could rearrange it. I could put pi and h together. Right? And then I could take the pi and the h and transpose them one time. So c squared is equal to v divided by pi h. And then what?
Transpose the square.
So c is equal to the square root of v over pi h. So everybody cool with that?
Yeah.
Alright, Shazay, Caitlin, y'all are okay?
Yeah.
Alright, lovely. So we didn't do all. Are there any others here that you would like to take a look at? I mean, I think they're all pretty straightforward here now that you guys understand what to do. So today, what we're going to be doing is we're going to be doing a review of the laws of indices, right? So we have our laws of indices here. Now, we did the laws of indices just a couple of weeks ago. What we were doing is we were doing number theory. We were doing just basic arithmetic. And we were taking a look at how the laws of indices are used in normal numbers like this. Normal numbers, and how the laws of indices could be used. Shazay, you weren't around, but Caitlin and Scotia, do you remember when we did the laws of indices?
Yeah.
Alright, very good. So what we're going to be doing now is we're just going to be reviewing the laws of indices. And you can see here that this law is given in an algebraic form. Algebraic means that instead of using actual numbers, I will just use symbols because these symbols can represent any number. So it's a generalization, right? So I have this first rule here that I want to take a look at. And that first rule here is a to the power of m multiplied by a to the power of n is a to the power of m plus n, right? I want you guys to prove this. How can we prove that this is true? How can we prove that it's true? And we did the proof for this last time. Last time when we did the laws of indices, we actually did the proof. Well, tell me, what is it?
Suppose like multiply the a by the amount of times m is to prove to
Right. So at the end of the day, we could multiply a m times, right? But we don't know what m is. So let me choose some small little numbers then. Alright? So if this rule is true, then it should be true that a squared times a cubed is going to be equal to a square plus cube, the 2 plus the 3, which is a to the 5. So the rule, according to the rule, this should be true. So let's prove if this is true. We have a squared, a times a, and it's being multiplied by a cube, a times a times a, and we can see that this is just a multiplied by itself 5 times, which is a to the 5th, and that is the proof. So you understand how to prove with Scotia and Shazay?
Yes, sir.
Right. So you're going to use a similar method. And in using that similar method, you are going to prove all of them. Right, so I'm going to leave them here. Right? And you see how with this proof, we just basically chose some arbitrary numbers for m and n. We chose some small numbers that would have made it easy for us to work out. You don't want to choose big numbers. But the base, we didn't have to choose a number for the base. It doesn't really matter what number the base is, as long as the bases are always the same. Right? So these laws only work when the bases are the same. So we just proved this one. You have this one, 2, 3, 4, 5, 6, 7 here to prove, right? So so prove all 7 of them, and I'll give you guys 10 minutes, right? So yeah, Scotia.
The second one?
Yes, what we are saying is, if you have something, when you're dividing two things that have indices, you minus the indices, right? So how do you prove this?
Well, I substituted the m and the n. After n was 3 and n was 2.
So a to the 3 divided by a to the 2, and that is supposed to be equal to a to the 3 minus 2, which is a to the 1, eh? So how do you prove this?
I have a times a divided by a times a.
And we can see that these two will cancel with these two, and I'll only be left with 1 a to the 1, and therefore it's true. Alright, Shazay and Caitlin, did you guys do this?
Yes, sir.
Alright, lovely. So out of Shazay and Caitlin, who gonna do this one?
I'll
Mm-hmm.
So I put M as
A squared,
and N as E.
and according to the rule, that is supposed to be a to the power of 2 times 3, which is a to the power of 6, right? So how do we prove this?
I wrote out A by E. I put those in brackets. And then I put multiplied by different brackets again. A by those brackets.
And then this is?
E to the power of 6.
Yeah, but I only seen 5 A's here.
Oh, well.
So this is not a to the power of 6. Right? Good try though, Shazay. Very good try. Let me show you where you went wrong, right?
Yeah.
So the inside the brackets is a squared, right? So a squared is a times a. All of this is being cubed, and
Yeah.
right. So therefore that is a times a being multiplied by itself 3 times, and
Yeah.
you see where you went wrong?
Oh, yeah.
So the a times a is being cubed. So that will give you a times a times a times a times a times a. So now I have 6 a's, and I can say that is a to the 6. You understand, Shazay?
Yeah.
Yeah, so you see where you went wrong, right?
Yeah.
Good job. Don't worry, that's quite a normal mistake, and they only getting harder and harder. So I'm real sorry for Caitlin or whoever is handling this next one, and I assume it's going to be Caitlin. Any number to the power of 1, that's not right. Any number to the power of 1 is itself. How do you prove that, Caitlin? Caitlin, any idea? Did you get through this one?
No.
Alright, no problem. Did you get through? These two here are the hardest one. Caitlin, did you get through this one?
Yeah.
Really? Okay, well, how did you get through that one? Let's see you do this one.
I substituted the zeros. So I do a to the power of 1 divided by a to the power of 1.
Right. So I wouldn't say substituted the 0, because 0 is 0, right? You have no m or n here, right? But what you did was absolutely correct. Absolutely correct. She used a previous rule. She used the rule a to the m divided by a to the n is equal to a to the m minus n. We already proved this to be true. So then what she did was she said, well, okay, a to the 1 divided by a to the 1 is equal to a to the 1 minus 1, which is a to the 0. The thing is, though, that a to the 1 and a to the 1 is the same thing. We know from SCA that if you divide something by itself, the answer is going to be 1. Yeah? So this is how she proved this one. Shazay, you understand this proof?
Yes, sir.
How about you, Scotia?
Yes, sir.
Nice. Can anybody prove this one up here? No. I'll give Ollie a hint and I'll let Ollie think about it, right? The hint is you have to use a sequence for this one. So for this one, here you had to use a sequence, right? The sequence is use what you know. You know that a squared is equal to a times a. You know that a cube is equal to a times a times a. You know that a fourth is equal to a times a times a times a. Right? So how can we use this, and so on and so forth? How could we use this to prove this? Caitlin and Scotia, huh?
I know how to phrase it.
You don't know how to phrase it.
Yeah.
Okay. Well, watch how easy it is, right? Given that you know that this is true, if I was to take a to the fourth and divide it by a, I would get a cubed. If I was to take a cubed, divide that by a, I would get a squared. If I was to take a squared and divide it by a, I would get a to the 1, which is a. Cool. See how easy that was? Everybody understand?
Yeah.
Yes.
Alright, so sometimes when you're proving things, you want to prove something to be true, you have to use what you already know, and you have to make sure that whatever you are using is already understood to be true. Yeah, you can't use something that is not proven yet. So anybody prove this one? Nobody proved this one? No? Shazay, Caitlin?
No, I have some class.
Well, let's just it's just one thing m here, m. So if you have a fraction, a numerator, and a denominator all to the power of m, that is the same as if you had the numerator to the power of m divided by the denominator to the power of m. Now this is a rule that especially in CSEC algebra a lot of people miss. So that would say that if I had 3 over 4 squared, that is the same as saying 3 squared over 4 squared. Right? Another thing is if you have 3 squared over 4 squared, you are supposed to recognize that that is the same as 3 over 4 squared. So all of these rules you guys are supposed to know real good. Right? So let's prove this one here. We'll use a over b all to the power of m, and we're trying to prove that that is equal to a to the m over b to the m. Well, let's see, right? Let's choose m to be 2. So we have a over b squared. What is a over b squared? A over b squared is a over b multiplied by a over b. And we know that when we multiply in fractions, you just multiply your numerators, a squared, and your denominators, b squared. Hence, proof. Everybody understand this one? Alright, Shazay, you okay with this?
That's all you have to do.
Doesn't it make sense? Does it make sense to you?
Yeah.
Didn't we just show that this number here is the same as these numbers here?
Yeah.
That this squared could just be this squared here, and this is the proof for it, then? Yeah. Isn't this how we did all the rest of them with choosing m to be a small number?
Yes.
Well, any questions? You okay with this?
Yeah.
You sure? You write it down?
Yeah.
I hope so. What about this one now? Anybody did this one? And this is another really super important one in algebra. Alright? If you have 1 all over x squared, that is the same as x to the power of negative 2. Yeah? And this is something that a lot of people forget when they're doing algebra. Also, if you see something like x to the power of negative 2, you're supposed to remember that is 1 over x squared. We call the negative 2 a reciprocal, right? Because it's flipping the entire thing. Now let's prove this. How are we going to prove this? 1 all over a squared is equal to 1 all over a times a. Anybody prove this? Yeah? What about this one? Anybody prove this one yet? No? So how do you get this negative 2 to be, you know? What is a to the power of a negative number? What is that? Well, we could use, guess what? We already did prove it, right? Because look, if I have a to the power of 4, you know that is a times a times a times a, right? And if I was to take a to the power of 4 and divide it by a, I would get a cubed. Everybody understand that so far? Alright. If I take a cubed, a times a times a, and I divide it by a, I would get a squared. Caitlin, Shizzy, are you okay with this so far?
Yeah.
If I had a squared and I divide it by a, I would get a to the power of 1. And which is itself, which is just a. And if I take a to the power of 1 and divide it by a, I would get 1. And 1 we could say is a to the 0. And right? So now if I take this one and I divide it by a, yeah, I would get a to the power of negative 1, which is 1 over a. So you see how we created a sequence going in this direction. And now if I take this same one and divide it by 1 over a squared, we will get a to the negative 2. And it's just going in the sequence, going down the road this way. So 1 over a cubed would be a to the negative 3. Everybody understand?
Yes, sir.
Right? You notice how the a4 and cube and thing was in the numerator on this side. But then we come across here and it becomes in the denominator on this side. So this is a times a. This is a times a times a. Shazay, how you feel about it? Shazay, I'm not hearing you properly. You're sounding far away from your mic.
I understand.
You understand? Caitlin, how you feel about it? Alright. So, given that, so we could tell now this here, this negative thing, is a real big one, eh? Is a real big one. Now, what I'm going to show to you, remember when we were doing this last one here, and I'm not sure if I'm going to prove this one. I might leave that for all you for homework to prove that one, right? But remember that what I was showing you guys is that a to the power of a half is actually the square root of a. Remember when we were talking about that last time? Right? How could we prove that? A to the power of a half is equal to the square root of a. What if I have, look, watch how easy the proof is, eh? Watch. A to the power of a half all squared. And we know from the previous rule that is a to the half multiplied by 2, which is a. Yeah? So therefore, if I was to take this and square it, you would get a. And you know that the square of a square root is a. Right? Now, at the end of the day, I'm just reminding you guys of this. I am just reminding you guys that a to the power of a half is the square root of a. A to the power of a third is the cube root of A. Therefore, A to the power of 1 over m, A to the power of a fraction, is that root, the fraction root, the denominator root of A. Right? You guys understand this rule here? Right. Now, if I was to take, sorry, Shazzy. Right. So, if I was to take this rule now, and I was to say, you know what? Right. And let's change this from m. Let's change that to y, because we see in here the denominator here is y, and it's the y root. Right. So instead of m, let's use y. So 1 over y is equal to the y root. And I hope you guys are writing this down. So if I was to take this a into 1 to the power of 1 over y and multiply it by x, we know that a, right? Just now, multiply it by x, then that would be, if we had this, not multiply by x, sorry, a to the power of 1 over y, all to the power of x, right? That would mean that we have the y root of a being all to the power of x. And we very well know that when we have this brackets, you multiply both of these signs here. So that is a to the 1 over y multiplied by x is the y root of a all to the power of x. And therefore, a to the power of x over y, right, is equal to, you just take your denominator, that is the y root of a, and it's all going to be to the power of x. So, Kateen, you see these two here at the CSEC level, or they should be really familiar with these two. These two will help you all out a lot. Right? So if you have something to the power of a fraction, a to the power of any fraction, that is equal to the y root of a. And if you have a to the power of a different kind of fraction, that will be to the y root of a, all to the power of that numerator number there. Right? Shazay, Scotia, Caitlin, how you all feeling about this? Okay, yeah, how about okay from Scotia? What about you, Shazay?
Yeah.
Yeah. Alright, what about you, Caitlin?
Okay.
Alright, you good?
Yeah.
Let me see how good all it is, right? I hope you all have the laws of indices written down there. Hello?
Yeah.
Alright, Shazay and them, all they have all the laws of indices written down, right?
Yeah.
Right. So rewrite the following expressions using positive indices only. You're trying it in your book silently, or?
I think, yeah.
Look at the rules. Look at the rules. Does it resemble any of the rules? What about this? Wait, before I give the answer, Shazay and Caitlin, you all have anything to contribute for this one? Alright, watch this. Let me see if you agree with this. This is equal to 1 to the power of negative 1 all over x to the power of negative 1. You all agree with that? Shazay and Caitlin, yeah?
Yeah.
I'll you remember the rule that says this? Sorry, where did it go? Where did it go? Where did it go? Alright? So Shazay, you remember the rule that says this? Right. So 1 to any power is just 1, ain't? Right? So 1 squared is 1, 1 cubed is 1, 1 to the power of 0 is 1, 1 to the power of negative 1. So 1 to any power is just 1. So now I have 1 over x to the negative 1. And then what? What will I get? Right. So let me write down the rule. So to get from here to here, we use the rule that if I have a over b to the power of m, that is a to the power of m over b to the power of m, right? So that's how we get from here to here. So how we get from here to here is just knowing that 1 to the power of anything is just 1. So we didn't really switch, we didn't really change anything here, right? So how do we get from here to here? Does this resemble any rule that you know? Look at the list of rules you have there. What about this rule, right? A to the power of negative m is equal to 1 over a to the m. You remember that rule? Right? So what I have to do, well, look at what you have to do. If I have 1 over a to the m, right, and I bring that up, it'll become a to the negative m. So I put a negative in front of whatever the indice is. You all understand that? Caitlin?
Yeah.
1 all over a to the m is equal to a to the negative m. Right? So therefore, if it is that I bring this a up, I just put a negative in front of that indice there. So I could do the same thing for the x. The power of x is negative 1. So if I bring the x up here, it'll be to the power of negative 1. You all understand? Shizzy? Caitlin? So now I have x to the power of positive 1, which is just simply x. So all you understand how I got that? Anybody have any questions or problems? No. And this number 32 here should be really easy. Number 32 is just one of your rules, right? So remember what we want to do. We want to rewrite the expression using positive indices only, right? So I have y to the power of negative 3 to a positive indice. What'll that be? Quick. You don't even have to do no steps for this. 1 over y to the power of 3. That is a straight rule. The rule is a to the power of negative m is equal to 1 over a to the m. Shizzy, you okay?
Yes.
Alright, you okay with this number 1, Shizzy? Would you like me to do over the number 1, Shizzy? Number 31. I'm not hearing what you're saying properly, you know. You put your mouth close to the mic or something.
No, sir.
So you don't understand number 31?
I understand it. I completely but
Alright, well I'm gonna do it over because understanding it completely is super important, right? At the end of the day, the idea here is that we need to know our laws of indices. So I have 1 over x to the power of negative 1. And I could say that that is 1 to the power of negative 1 all over x to the power of negative 1. And the rule is that the rule is that a over b to the power of negative to the power of m is equal to a to the m over b to the m. So do you understand this part?
yes.
Right. Now the second part, all I saying is anything 1 to the power of anything at all is just 1. Right? So therefore that is just 1 all over x to the power of negative 1. You understand how we got that?
Yes.
Right? So now we could recall that, hey, 1 all over a to the m is equal to a to the negative m. You understand this rule?
Yes.
Right? So in terms of when we bring the a up, right, we have to put a negative in front of the indices. So we could say that we could bring the x up, and this is the indice, but we have to put a negative in front of the indice. You understand that?
Yes.
And now that negative minus 1 is just x to the 1, which is x. You understand it now?
Yes.
Alright. Now these here, number 33 to 37, are super easy. So let's get it going real quick. Where's number 33? Simplify the following expression.
Yeah, add the
Don't tell me what to do, tell me what to write. Write it out. What? Which is what? 6n. Everybody understand that? Shazay, you okay with this?
Yes.
Alright. Shazay, give me number 34.
That would be a to the power of 3 plus 5 minus 2.
You could say 3 plus 5 plus negative 2 just to be safe. But it's the same, which is what? A to the power of?
A to the power of, sorry, A to the power of 6.
Alright, 5 and 3 is 8 minus 2 is 6. Right. So number 35. Caitlin.
X then 160 plus 4 plus 3 x to the power 9.
Somebody give me this one. I'll let you volunteer.
I'll do that one.
So what is p to the power of 8? What is the rule? The rule is that if I have a to the m, all in brackets, to the n, that is a to the m times n. And?
Yeah.
So you have to remember that this p is to the power of 2, but this q is to the power of 1. And?
Yeah.
So I will have 2 times 4, which is p to the power of 2 4s are 8. And then q to the power of 4 times 1, which is 4. See what I do there? Shazay, you see that?
Yes.
And that is being multiplied by, same thing on this side. So somebody give me this side. Yeah, because 5 times 1 is 5. But we ain't done yet. Simplify that now. Right. But what? Just now, wait. Where did we go? What can I add? What do I add? You could only add the like bases, eh? So I could add the q's. So that is q to the power of 4 plus 10. And then that is being multiplied by p to the power of 8 plus 5. Eh? So that is q to the 14 times p to the, where's 5 and 8? 13? Right, and this is the answer. Caitlin, how you feel about this?
Okay.
Alright, Shazay, how you feel about this? You understand?
Yeah.
Alright, well, if you understand, Shazay, give me the next one. This times this. Mhm. Are these different? So there's nothing I could do with that, eh? I can't do anything. Once the bases are different, I cannot do anything with it. You understand, Shazay?
Yes.
Multiply by what? This side now. Just give me it real quick. Where you know this rule is? Where this had to do to here?
Yeah.
This 2 by this 4. Huh?
Yeah.
So 4 2s are 8, huh?
Yeah.
So that's a to the 8, correct?
Yes.
And then that's b to the 8 as well, huh?
Yes.
Alright, simplify that now.
Plus 8
Times. Multiply by b.
times.
B to the 8 minus 2, eh?
Yes.
Right? And that will be 8, 9, 10, 11. A to the 11 times b to the 6. You understand?
Yes.
Nice. Caitlin, you okay?
Yeah.
Alright, I hope you guys have been writing down. I want you guys to do those questions, but I also have some other very important questions here to ask you. So maybe we could do these questions next week. Alright, so we will take, these are some simpler questions here, but we will take these questions next week. They're real important, right? But before we go, because we only have a couple minutes in the class, so we're over a little early. Before we go, take 5 minutes, 1, 2, 3, 4, 5, and do these. Rewrite the following expressions using positive integers only. You have 5 minutes, right?
I'm stuck.
You're stuck? One, which one?
Number 2.
Number 2? Alright, let me get going. A to the power of 2, all to the power of 0, times a to that. Well, we know anything to the power of 0 is 1. And 1 multiply by this will just be that. A to the power of a half times 4. So this entire thing just get cancelled out there because anything to the power of 0 is 1. Everybody understand this so far? It are done, but you understand it? You understand it so far, Caitlin and Shazay?
Yeah.
So therefore, using this rule, that is a to the power of a half multiplied by 4, which is a to the power of 2. You all got that?
Yes.
Yeah.
Okay. Caitlin, were you stuck on number 2 as well?
Yeah.
Yeah, alright. So, number 2 is actually quite easy. This is, crap, stop calling it. 2x to the power of negative 3. So I have 2x to the power, all to the power of negative 3 divided by x cubed. Could we say that this is 2 to the power of negative 3 times x to the power of negative 3? Could we say that?
Yeah.
Divided by x cubed? could we just separate this 2 to the power of negative 3 now, pull it on the outside, so I have 2 to the power of negative 3 being multiplied by x to the negative 3 all over x to the 3. Could we do that?
Wouldn't 2 to the power of negative 3 still be over x cubed?
No. If it was adding, yes. But remember, this is multiplying. So this is really 2 to the power of negative 3 over 1, and so what's happening here is if I have, remember when you're multiplying fractions, so if I have, say, 2 over 1 multiplied by 3 over 4, I could just multiply, alright, not 3 over 5, sorry. I could just multiply my numerators and my denominators, right? So I'll get 2 times 3 over 5, and over 5 times 1, right?
Yeah.
Right? So isn't this the same thing?
Yeah.
Yeah? It's the same thing, right? Alright, so this is 2 to the power of negative 3 over 1 multiplied by this fraction. And you multiply your numerators, so you'll get this. And you multiply your denominators, you'll get this. Shazay, okay?
Yes.
Right? So you could see here that this rule to get from here to here, that wasn't no algebra rule, you know. That is not an algebra rule we use there. That is a normal multiplication of fractions arithmetic rule that we use there. To take that negative 2, to take that 2 to the power of negative 3 out. Right? To take that 2 to the power of negative 3 out. So, are we okay up to this point?
Yes, sir.
Caitlin, you alright?
Yeah.
So now that we separated that 2 to the power of negative 3, we could apply the rule to this. So we have the 2 to the power of negative 3 over on this side, and that's being multiplied by, and in this bracket, when we're doing this, that is what? X to the minus 3 minus 3. Would you agree with that? And when you're dividing, you just minus the indices, huh?
Yes.
Right. So now I'll have 2 to the power of negative 3 multiplied by x to the power of negative 6, and right. So therefore I will have 2 to the power of negative 3 being multiplied by 1 over x to the 6. Make sense?
Yeah.
Right? But guess what? I could take this 2 to the power of negative 3 and say that that is actually 1 over 2 cubed multiplied by 1 over x to the 6. And
Yeah.
And that means that this is 2 2s are 4 2s are 8, 1 over 8 times 1 over x to the 6. And I could just multiply my numerators and my denominators, which gives me 1 over 8x to the 6. How will you feel about that?
Have a lot of steps to it.
Not really, you know. Like all of these steps here, right? You could see that for some of them I use my laws of indices, but for some of the other steps I use basic arithmetic laws, right? And this is the whole point that I was trying to get to you guys. The whole point is that when you are dealing with algebra, you treat it just like if you're dealing with arithmetic. You just remember they are numbers. Yeah? Caitlin, how are you feeling about this?
Okay.
Yeah? So it makes sense to you, Scotia?
Yeah.
Alright. Yeah. Why are you sounding so sad? You want to go?
I'm not sad.
Yeah, you're sounding sad to me. Shazay, you alright with that one, right?
Yes.
I hope so. You want me to do that one over? So what we have here, the next one. The next one, I have 2a squared b to the negative 2 all over 2 to the negative 3 b to the negative 4. Any ideas?
I thought that since the B's are the same, we could do 0.
Right. But let's see if we can split. Because everything is being multiplied, would you agree that this is true? 2 over 2 to the negative 3 multiplied by a squared b negative 2 all over b to the negative 4. Would you agree that that is true? Shazay, yeah? I just basically pulled the numbers out, and Caitlin, would you agree that is true?
Yeah.
And I could pull that a squared out as well. So I could say 2 all over 2 to the negative 3 multiplied by a squared over 1 multiplied by b to the negative 2 all over b to the negative 4. Would you say that this is true?
Yeah.
Shazay, you okay with this? Shazay, I'm not hearing you.
I said, yeah.
Alright, you sure? I'm feeling hard to move forward if people not sure, you know. Right? So you could see here that I can't do nothing with the a square will remain there. But I could work with this and I could work with this. Right? So let's tackle this one first. That is 2 to the power of 1 minus 3. And
Yes, sir.
Caitlin, you okay with that?
Yeah.
Multiply by the a squared, multiply by b to the power of negative 2 minus the minus 4. And
Yes, sir.
And this is where you have to be careful, right? Because a lot of people might want to put b to the power of negative 2 minus 4. But this would be wrong. This would be wrong. Because I have a to the m all over a to the n is a to the m minus n. So this minus sign is between the m and the n. So I have the m here, negative 2. I have the n, which is negative 4, and I have the minus in between. You understand that?
Yes, sir.
So these are the mistakes that students would normally make. Same thing here. Yeah? Same thing there. So that is 1 minus 3 is 2 to the power of 4. Right? Times a squared times negative 2 minus 4 is negative 2 plus 4, which is 2. So that is b squared. So the answer is 2 to the 4 a squared b squared. You all okay with that?
That's right.
Sorry? Oh, yeah, sure. Sorry. Let me know if I'm going too fast. Let me know if I'm going too fast. So we'll actually do the rest of this sheet next week, or Tuesday, right? On Tuesday we'll do the rest of this sheet, right? Now at the end of the day, you're seeing here that the laws of indices, right? The laws of indices are just laws that you have to know. Now we went and we proved each one of them, so you could see why each one of them is true, and you could see why each one of them are important. Yeah, so each one of those laws are true, each one of those laws are important, you have to know each one of those laws by heart, especially for CSEC maths. You have to know it. Remember, algebra is no different from arithmetic. So all of the same rules still apply. The rules for adding fractions, the rules for multiplying fractions, basic rules for commutativity, yes. Those basic rules when it comes to multiplication, division, addition, and subtraction, all of those rules still apply. That is the reason why I did arithmetic first and then I did algebra right after, to show you both of them are in fact the same thing. Yeah. So now with these laws of indices, we're starting to get a little deeper into it. We're starting to get a little deeper into the whole maths thing. So you guys are required, especially those last two laws, you're required to know them and understand them. Yeah. So you'll see here. Let me share my screen. If you go in your CSEC math, everybody seeing this? Right. So we started with the welcome, we started with number theory. Then we go on to intro to algebra. Now we are actually on class 12. This class is class 12. I did not upload class 11 yet, but I will upload that tonight. So tonight I will upload class 11 and class 12. So by tonight you should have those, right? This coming down here, this was the last assignment that you all did, Intro to Algebra 3. Over here, we have the Laws of Indices assignment. And in this assignment, I have this chart here showing you all of the laws of indices so you can revise them. And these are your questions. There are 50 questions. It's just one page. There are 50 questions. Most of the questions are easy, right? Most of the questions are easy. You can see some of these questions are questions that we were just doing, right? So see if you all could tackle these 50 questions here for homework, right? And we will do those questions later on. They start real easy on this side. The first 30 are quite straightforward, but then the other 20 here on this side are a little bit challenging, just a little bit, right? So, anybody have any questions? I'm feeling like if this class was not as clear as some of the other classes. How you all feeling about that?
I need to practice.
You need to practice. How about you, Sandman?
I understand, like, when you get down to the part where you're applying the rules, I understand that, but when when I saw the question, just as I was kind of confused as to how to start.
Right. You don't understand how to apply your rules. Yeah? You understand when I apply the rules, but you don't understand which rules to choose, and
it just had like some things in it that I didn't do that you could have done that, and I was working how it was to do it.
And those things that you're talking about, those things are actually arithmetic things, like pulling out the 2 from the fraction, and
yes, sir.
Those are arithmetic things. Yeah, so that's why you should really go and look back at those arithmetic videos, because we covered all of that. We did laws of indices already, you know.
Yeah, I remember.
No, not with you. I talking about last month in one of those classes that you missed. Yeah? In one of those classes that you missed, we had a whole class on the laws of indices. We proved a lot of them already, which is why this proving thing got me a little vexed, because I could not prove it. Okay? And we took a look at some questions pertaining to arithmetic. Yeah? But now we're looking at it pertaining to algebra. And we see, and the whole point is that we're seeing that there's the same thing. It's the same thing. Yeah? So, Caitlin, you okay?
So far, yeah, hello.
Right. So I guess all of you need practice. Now, when it comes to Shaze's question of when you look at a question, how do you decide which law to use? Well, it's really just literally up to how the question looks. How the question looks will give away which law to use. Like if the question is a fraction, then obviously you'll be thinking of those laws that have to do with fractions. Right? If the question have an indice inside with brackets and an indice outside, you'll think about those laws that have to do with brackets. You understand, Shazim?
Yes.
So literally look at the question, and how the question looking will give you a clue as to what laws to use. But again, the reason why I could do it is because I know all of my laws by heart, and I know them very well, all of them. Yeah, and that is what you guys need to do. So I hope that this exercise will get you to do that. This is just the introduction to algebra. However, we will be doing laws of indices again. We will do another revision for laws of indices when we move on to algebra 2, but we wouldn't move on to algebra 2 until next year. This year we still have things like sets and coordinate geometry and all of them kind of things to do this year. So we'll do algebra 2 next year. This is algebra 1, which is just an introduction to algebra, and the point of this was to show that algebra is no different from arithmetic. It's the same thing. Yeah, it's just that the numbers in algebra are unknown, right? So that's the whole point. I'll see you guys on Tuesday. Good luck with your assignment.